Hello and welcome to another IB Math speedrun. So in this speedrun, we'll be finishing off chapter 5.1 of the textbook, so let's jump right. So we need to know a bit more about sampling, and in specific, we need to know about the different sampling techniques. So there are a number of different sampling methods we could use to select a sample, and so we need to know the most well-known ones. So the first one is called simple random sampling. Simple random sampling. And so this is when each member of the population has an equal chance of being selected, and so they're more or less selected at random. So it's like you label everyone from 1 to 3 to like 100, or how many members your population has, and you simply go to a random number generator and generate random numbers until you meet the number of random numbers that you need in your sample. And then you just get all of those units and take your information or data off them. So that's simple random sampling. Okay, so the next one is called systematic sampling. And so here is where we list the numbers again, and we select a sample according to a random starting point and a fixed interval. So we still need the random number generator. Say our random number generator pops out 2, and since we have 100 terms, we want to get 20 from all of these 100. So we'll start at the second term, and we'll get this, and we'll get every 5 terms. Since we need to get 20, 100 divided by 20 is 5, so we need to get every 5th person. So remember that simple random sampling is just generating 20 random numbers and getting the values of them. Systematic sampling is when we go every 5 people, actually, so this would be 7, and then get that person. So continuing with our example, we have stratified sampling, and so this involves dividing the population into non-overlapping smaller groups and then choosing a random sample from each group to form your sample. So an example of this again is we have the numbers 1, 2, 3 into 100. So we could divide this group of 100 into smaller groups of 5, let's say. So we have 1, 2, 3, 4, 5, and then we have 6, 7, 8, 9, 10. And from each smaller group, we will choose a certain member through a random number generator. Say it's 3 here, say it's 7 here, and we will use these units to gather our sample instead. So next we have, where is it? Let's put it over here. Next we have quota sampling. And this is much like stratified sampling, but takes a sample size from each one in proportion to the size of the population. So this is where we already know something previously about the population. I don't know, say that we are surveying a school that has 75 kids in 9th grade and 25 kids in 10th grade. And we still need to sample 20 of this total population. So in stratified sampling, we would simply pick like 25 here, 25 here, 25 here, 25 here, and then we can get, we need 20 kids, so we can get 5 from here, 5 from here, 5 from here, and 5 from this last one. Remember, these are all groups of 9, and then this one is the 10th grade. But in quota sampling, we will get the groups in proportion to their size in the actual population. So if there was 75 from 9 and 25 from 10, then this means that we would want to get 75% of the sample as 9th graders and only 25% as 10th graders. So that's the difference. In quota sampling, we're making sure that the sample has proportionate characteristics to the real population. And finally, we have convenience sampling, which is by far the easiest method. And this simply involves selecting the members of the population who are most available. So if we had 100 students or 100 whatever, say 100 students, again, convenience sampling would just say to select the first 20 that you see, because those are the most easily accessible. Or say you go into a class and interview all 20 members there, or something like that. You just get the most easily accessible members. Yeah. And so, so with all these different sampling techniques, as long as the sample is relatively random, and we can see we have different types of randomness here, then the mean of the sample is roughly equal to the population mean, so we could use the sample as an estimate for the population. So the only other thing we need to talk about is kind of bias in sampling. And so bias in a sample is concluding some incorrect statistical information from the sample that does not correlate with the whole population. So this tends to give a skewed interpretation of the general population. So it's like, say, the 25 people we interviewed in our sample all say they like soda. But out of 100 people, if we were to interview the entire population, only say 33% actually liked soda, and I don't know, the other 66% liked water. This is an example of being skewed, so it means that this is why it's essential that each sample is actually representative of the population, so that we eliminate as much bias, because we want to get the best information we can of the actual population using our sample. So what are some sources of bias? So some sources of bias include some members of the population being excluded from the sampling frame. So this is a pretty obvious one. Like if we never include, say we have a school that's 50% boys and 50% girls, if we only choose boys for the sample, that means that we won't get the opinions of girls, and so this might be biased. So the sample might conclude strongly in favor of the opinions of the boys, whereas it doesn't give a real representation of the entire population and excludes the girls. So that's one problem. Second problem is a non-response. So this is when some of the samples or recipients of the sample don't send their answers back, or just refuse to give their information. So because the people that refuse to give their information are a subset of the population itself, this means that they might have very different opinions than the people that actually gave back the information, and so this can cause bias in the sample. The third one is just bad design. So if the questionnaire or whatever sample you're doing is biased inherently, if it has leading questions or if it's confusing, then it might lead respondents giving misleading information and the sample being biased. And finally, we have bias by the respondents. This is because people don't like to tell the truth if it's negative. If you went around a school and surveyed all the kids and asked them whether or not they, whether or not they were satisfied with their grades, it would be maybe a lot more kids might say yes, they were satisfied, just because it's harder to tell the truth, and so this is the hardest bias to eliminate at all. Or like if you went around the school and asked kids whether they thought they were overweight, I don't think any kids would say they were overweight. So yeah. This leads them to give untruthful answers, which inherently biases the sample. So finally, the reliability of data. What is reliable data? So data is reliable if we can repeat the data collection process and obtain the same answer. So if we have our answer here, we have our data collection process. No matter how many times we repeat the process, we should always arrive at the same answer. So, for example, we could repeat a survey or experiment, and we should expect to get the same results each time. So, data is also sufficient, which is different from being reliable, if there is enough data to support the conclusion. So, for example, if you were interviewing 100 people, and you got, say, at least 50 or like maybe 25 of them to respond, then I would say that data is sufficient. But if you were interviewing 100 people and only got 2 of them to respond, then I don't think this is sufficient to give a good conclusion. There's no fixed value for how many items you need out of the entire population to be sufficient, but it should just be representative of the entire population. So what can cause unreliable data then? We've talked about reliable data doing the same thing and getting the same answer. Well, what can cause unreliable data? The first part is missing data. And if data is missing, then it reduces the validity of a sample and can distort whatever data you collected about the population. And they're, of course, excluded from analysis. You can't analyze data that you don't have. So if only a few values are missing, that's perfectly fine. But if you have a large proportion of missing data, then it can become seriously unreliable. And the second thing is errors in handling the data itself, because data might be entered into the system incorrectly, or some analysis might have made some mistakes, or something like that. And this can all affect the reliability of the data. So we want to ensure that we have the least amount of missing data possible and the least amount of errors in handling the data. And we can reduce those by peer checking and also by, missing data, I guess, by following up with data we have not collected yet. With that being said, let's move on to some questions. I'll do the even ones. So we have a non-governmental organization, which is an NGO, would like to take a sample from its various worldwide bases to give some information about its results. Below is a list of the number of bases the NGO has in each continent. And I'll put that. So first we need to describe how you could use this information to conduct a stratified sample, and discuss the advantages and disadvantages of using this technique. So the information being that they have, in Europe, they have 57 bases. In Africa, they have 35 bases. In Antarctica, they have 2 bases. In Asia, they have 35. In Oceania, they have 57. In North America, they have 85. And in South America, they have 35. So, how can we use this information to conduct a stratified sample? Well, we already have subgroups of the population. So, if they wanted to conduct a stratified sample, what we would do is we would pick one person from each of these subgroups, or say one base from each of these subgroups, and use the mean of those bases to get the result of the overall thing. That's stratified. Remember, there's a difference between stratified and quota. So, what are some advantages of using a stratified sample? Well, it allows them to get a feel of how their performance is over each continent, and so just, by averaging it, they get a rough value of how their performance has been throughout the entire world. And it also ensures that there's at least one representative from each continent that's being sampled. So those are the 2 advantages. However, one obvious disadvantage is that they have several more bases in certain places. So in Europe, Oceania, and North America, they have significantly more bases, and so the sample might not be representative of the performance in those bases. Say that North America as a whole was performing excellently, but Antarctica was performing poorly. If we only take one member from each one, they would cancel out. Whereas if we looked at it as a whole, and you say using a quota sample, and we looked at the 85 performing well versus the 2 performing poorly, it's clear that their progress has been much better in North America, and therefore as a whole. So yeah, those are two different opinions. And let's move on to the next one. So the next one is a bank prepares statements for its clients at the end of each month. A machine seals the envelopes. A batch of 50 envelopes is inspected to see whether the machine is sealing properly. Identify the variable, sample, and population. State whether it is discrete or continuous. Okay, so let's see. The variable here is clearly how is the envelope sealed? Or like number of envelopes correctly sealed is probably the variable. Okay, because that is what we're measuring in each batch. So the sample is 50 envelopes from the bank, from the machine. And the total population is all of the envelopes that the bank sends to its clients at the end of each month. Excuse me. And, well, whether is the variable discrete or continuous, well, it's clearly discrete because we're counting 50 envelopes. 50 envelopes is something we can physically count, and there's a finite limit to how accurately you can measure 50 envelopes. You can't say there, that 48.528 envelopes were correctly sealed. You can only say the natural numbers, really. And so there's a limit to how accurate you can be, so therefore the data is discrete. Okay. Now, on to the final question. And the final question is, the government would like to gather information on a new standardized test for all 16 to 19-year-olds in the USA. A random sample of 15 schools in each state is generated, and each student aged 16 to 19 in these schools takes the test. Describe what type of sampling this is. So we have a random sample of 15 schools in each state. So the total population is all of the states in the United States. All of the 16 or 19-year-olds in the United States. And, well, we're separating it based on state. Since we're separating it into groups, this is either stratified or quota. Excuse me. This is either stratified or quota sampling, since those are the only two sampling methods that involve dividing population into smaller groups and then picking a sample from each one. And since we're getting an equal amount of, well, in this case, schools from each state, we are using stratified sampling because that gets an equal amount from each group. So if we were doing quota sampling, we would say, well, let's say we'll get 10% of the schools in each state, and so in states with more schools, they would have more schools being surveyed. But in this case, it's not, it's stratified sampling, so that's what the type of sampling is. So yeah, that's all for the speedrun. I hope you enjoyed it, and I hope to see you in the next speedrun. See you.